All right, so today we're really still talking about slope-intercept form. We're talking about it in the form of real-world context. So these are different types of word problems that you're going to see. The best way is just to get into this. It's all word problems, and so I'm going to go through with it and show you how to work these problems. So that's what we're looking at. Dracula has a swimming pool that has been infested with algae. He must drain the water and clean the pool in order to kill the algae. His pool holds 30,000 gallons of water and drains at a constant rate. The table below shows the progress of the water according to the hour. Okay, so then they give us a table. So they give us this little description, and then they give us the table. And they say, oh, well, after 1 hour, the water remaining in the pool is 29,600. And then they keep going through at 3 hours, at 5 hours, at 7 hours, at 9 hours. And they say, hey, we got a constant rate here of drainage. So, and then they come down here and say, well, which of the following equation represents the relationship from the table? So what we're taking is we're taking this table in this paragraph, and we're going to write an equation. Now, we want to write it in slope-intercept form, but if you take a look down here, it's not quite in slope-intercept form. Well, you could rewrite this to make it in slope-intercept form, and we're going to do that, but we're going to do that after we come through and we actually find our equation. We're going to do it in slope-intercept form, then we're going to take these and put them back into slope-intercept form, because we'll know, once we put ours in there, we'll know what the y-intercept is, and we'll know what the slope is. And it'll be easier to just pick out which one we should be using in order to rearrange. Okay, so that's what we're going to do first. Now the first thing we need to do is look at, do we have our y-intercept? Well, we do. We just didn't realize it until we read and gone through the table. We have it. His pool holds 30,000 gallons of water and drains at a constant rate. Right here is our beginning, it's our initial, okay? It's where we start with, okay? Well, where we start with is our y-intercept. So we have this, y equals mx plus 30,000. That's where we're at. We need our m, or our slope, okay? But we have our initial, our beginning. Now, from here, we need our slope. Well, we're just going to take 2 points here, put them into our slope formula, and find out what our rate of change is. Okay, so that's what we're going to do. 29600 minus 28800. And then you can't really see that, but that's how it's set up. Here, let me move this over just so that you can see it real quick, because I want you to be able to see this. 29600 minus, okay, and when I do this, I normally set it up like this, 2960, the x that goes with that y goes immediately underneath it, 1. Minus, because that's a part of the formula. All I'm using is slope formula right here. I took 2 ordered pairs, got the change in the y's over the change in the x's. 29600, 28800, and 3. Okay, now guys, I'm going to plug that into a calculator. I don't want to deal with that. I think it's 800, but I want to make sure. 29600 minus 28800. Yeah, 800. Okay, so I had that right. 800, that's that, over 1 minus 3 gives me -2. Okay, well, that reduces to negative 400 over 1, or negative 400. So what I have is a slope of negative 400x. So y equals negative 400x plus 30,000. Well, now I'm going to come down here, and first I'm looking for this number right here. Okay, so no, and then I have these two. Well, now look, 30,000, 30,000, minus 800x, minus 400x. I know it's not that, I could rewrite this. Y equals negative 400x plus 30,000. Okay, so this can be rewritten as this. Okay, this right here puts it in slope-intercept form. But if you know this, you can look at these and decide which one it is. You can do that pretty much without any problems. you knew immediately that these two weren't it, and then you're just trying to figure out which one of these two it is, okay? Be careful that you get to here and you don't put it in here. Watch that, okay? You gotta reduce this fraction all the way down. So be careful with that, all right? But we've been doing slope-intercept form now for a little while. This is a skill that we can do, okay? We're getting better at this. Shouldn't be that big a deal, okay? All right, so there's that one. Number 2. The graph below shows the relationship between x and y. Which equation correctly models the relationship on the graph? All right, so now we have a graph. We know that we're putting it into slope-intercept form, y equals mx plus b, and that b is the y-intercept. It's where this line crosses the y-axis. Well, where does this line cross the y-axis? Well, it crosses it right there. Okay, well, you don't go any here, you go down 1, 2, 3. So y equals, and now we're looking for our slope. Okay, first off, we can come in here, we can eliminate that one, we can eliminate that one. So now we just need to know which one of these two slopes it is. And the great thing about this is, look at this, 2/3 x, negative 2/3 x. If you know that this is a positive slope, that when you read it, you go left to right, that it's going up, I don't even have to use my slope formula to determine what it is. So this is what they're trying to get you to recognize. Is it positive, is it negative, and do you know the slope or the y-intercept, okay? So this right here, this is my answer because that's a positive slope. Now, if I wanted to actually find it, it wouldn't be that big a deal because I could take my order pair of 0, negative 3, and then I just need one other point, yep, right there, 1, 2, 3, comma, negative 1, and I get to put this into slope formula. Okay, so I'm going to put it in a slope formula. I'm going to go ahead and do this just because I want you to see how this comes out. Okay, so negative 1, negative 1 goes there, that means 3 goes there. Negative 1, 3. This is the y, this is the x, minus, minus, then negative 3, 0, 1, minus negative 3, click, click. 2, 3 minus 1, 3, 2 over 3, 2/3. Y equals 2/3 x minus 3. Okay? That's what you're looking to do here. Okay? Guys, we can do this. We can do this. Alright? So, not a big deal, especially if you know that this is positive and you know your y-intercept, you could have picked this out with not much of a problem. Okay? Alright. Same type of problem. Same type. First off, line's going down. Negative slope. Perfect. Anything that doesn't have a negative slope is wrong. That's wrong. That's wrong. So that leaves me this one or this one. Now I'm looking for, what's my y-intercept? Well, 1, 2, 3, 4, 5. Positive 5. Can't be that one. Has to be that one. Okay? Just reading the graph. That's all we're looking for. And putting it into y equals mx plus b. That's what it is. Once you understand that, these become so much easier. Okay? All right, number 4. Elmore has a savings account that he uses for his expenses at college. The table below shows his balance at the end of each week. If Elmer spends the same amount each week for his expenses, all of the following equations do not represent the relationship in the table except. So we're looking for the one that does represent it. Be careful with this that you don't just stop here. You finish reading out and you get the except, okay? It also tells us that it spends the same amount each week, so we have a constant rate of change. So as we're looking at this, we know we have a constant rate of change. We know we're looking for the one that does represent this. What we don't have is our initial. We don't have our initial. But let's find our rate of change. Well, let's start there. We'll start with our rate of change, then we'll go from there. Again, change in the y's, or the change in the x's. So 940, 1, minus minus, slope formula, that's all this is. 830, 2, 940 minus 830, you get 110 over 1 minus 2 minus 1. So it's going down 110 each week. So our slope is minus 110. Well, minus 110x. Now look, okay, some of these aren't in slope-intercept form. Y equals 940 minus 110x, y equals 110x plus 940, y equals 110x plus 1050. These two are in slope-intercept form. Their slopes are positive. I know it's not these two, because my slope is negative. Okay? But now I've got this, y equals 1050 minus 1. Okay, so it's one of these two. Now look, it can't be 940, because at week 1, we're down to 940. It can't be that, because our y-intercept can't be 940. Okay, so here, we're looking for what is our y-intercept. When is it, at week 0, we want week 0. Well, if it goes down each week 110, we're gonna add 110 to this 940, okay, and we get 1050 here, okay? Because if I go down 110 from here to here, that gets me there. That's what you're looking at. Be careful with this. It's easy to make a mistake on this, so watch that. But that's what it is. So at 0, we're at 1050. Right there is my answer. Even though it's in a weird form, it should look like this. I don't like it when they do that. It should look like this. Plus 1050. That's what it should look like. But sometimes they'll write things like this. You just got to rearrange it so it's in slope-intercept form. But that's what it should look like. I don't know if you can see that or not. But that's what it is. All right. Let's jump down here to 6. All right, we got a few more of these. Marissa is a bodybuilder who is getting ready for a competition. She must gain weight before a competition. The table below shows her weight log over the course of a few weeks. Okay? All of the following linear equations do not represent the relationship in the table except, again, we're looking for the one that does represent this table. Now, when we look at this table, 1, do we have a constant rate of change? She must gain weight before the table below shows her weight log over the course of a few weeks. We probably have a constant rate of change here, and we have one thing for sure. We have our beginning point. Where did we start? So we have our y-intercept. So again, y equals mx plus 170. Now we need our rate of change. So we're going to take these, 170 minus 183 over 0 minus 1, 170 minus 183, all right, is 13, negative 13 minus 1. Because I set these up kind of weird, I would have normally have switched them, but it's okay. Negative gets you a positive, so we have 13 over 1, so we're going up 13 pounds each week. And if you look, we got the same thing going on there, same thing there, and so on and so forth, and it's doing that. Okay, so we're going up 13, so our rate of change here is 13x plus 170. That leaves, we know it's not that one, we can get rid of that really easy. We know that it's not that one, that's easy. The difference between these two, this is it, this is minusing 13. So that means that they're losing 13 pounds, where here we're gaining 13 pounds each week, so it can't be that one. And that's the difference between those. All right, so these, not that bad, we can do these. We have a couple others that we need to look at real quick, and then we're going to be done. All right, these are the word problems. These are the ones that you're just going to read, and you're going to set it up. Leah owes her grandpa $91. She washes dishes and gets paid 4 per load of dishes, which linear equation could Leah use to determine y, the total amount of money that she has after washing X loads of dishes? Now, we're always going to set stuff like this up in slope-intercept form. When you read this stuff, it just is easier when you set it up that way. What you have to watch is sometimes they don't use y and x as your variables. Sometimes they'll use a and b, just depends on what it is. But it doesn't matter because it's still the same concept, right? What do you input? What do you get out? Okay. Which one is independent? Which one is dependent, right? This one changes that one. So when you're looking at this stuff, that's kind of what you're looking for. So we're going to set this up. Well, where do we start? Well, y equals x plus b, right? Well, how much, where do we initially begin? What did we owe? What do we have? Well, we owe Grandpa $91. Well, if you owe somebody that, that's minus on you. So you minus 91. You owe them that, okay? And gets paid $4 per load addition. This is your rate of change right here. So this is your initial, right? That's your y-intercept. And right here is your rate of change or your slope. So y equals 4x. If you get paid $4 per loads addition, you're gaining that, you're earning that. Okay, so y equals 4x minus 91. Y equals 4x minus 91. No, it's not that one easily. No problem. Okay, this one, maybe, but be careful with that because that's plus 91. You owe them $91. And then this one, the rate of change and these initial are in the wrong spot. Okay, so that's what that is. Once you've read through some of these a couple times, it starts to become easier to set these up. All right. Finn is a member of the monthly video game club. His monthly dues are $25, and he also receives a 10% off discount on any video game that he buys each month. Which equation could Finn use to determine why the total amount he has spent this month with the video game club after spending X original dollars? All right, so how much does it cost you to be just a part of the video game club? Well, y equals mx. Well, it costs you 25, and we're looking for how much you spend. So 25 is the initial fee. Well, so this is your y-intercept. This is what it costs you just to be a part of it. Okay? And then you have this 10% discount. Well, you can write 10% as 0.10. Okay, so remember when you did discounts or percentages down in 7th grade? This is that. So point You got also receive a 10% off discount on any video game that he buys each month. Which equation could Finn use to determine why the total amount he has spent this month with the video game club after spending his original deal? Okay. All right, so here's what they've done. Watch this one. This one's a trick question. It really is. Okay, so what they want you to do is do this and get it wrong. Okay, because that's what I was just about to do. They want you to do that and get it wrong. Because what they want to know is, how much are you spending this month, right? Well, you're getting a 10% discount. So how much are you really spending? You're only spending 90% on this. So what you really have is this. That's what you really have. Be careful. This is a trick question. They want you to pick this one when in reality, it's this one right here. Okay? That's what they're trying to do. They're trying to get you to choose this one. Don't do that. Okay? But you got to be careful with this. You got to watch that right there. 10% off discount. Well, if they're taking 10% away from it, you're paying the other 90%. Okay? So be careful. So it's y equals 0.90x plus 25. All right? So however many you buy, times that, okay? So be careful. This is a good question, it's tricky, all right? So be careful with that one. Very easy to make a mistake on one like that. Very easy, okay? Natalie loves to eat, still looking at that. Natalie loves to eat fruit. She currently has 10 bananas. She goes to the farmer's market and buys apples in groups of 6. What equation could be used to find y, the total pieces of fruit Natalie has in all after buying X groups of apples? So Natalie loves to eat fruit. She currently has 10 bananas. So she currently has 10. All right. And we want to find the total pieces of fruit that she has. Y equals X plus 10. She has 10. All right. She goes to the farmer's market and buys apples in groups of 6. Okay. Which equation could be used to find y, the total pieces of fruit? Okay, well, we need to know how many groups she buys because they're all going to be multiplied by 6. X represents the number of groups of apples she buys. 6 is the number that are in each group. 10 is the initial start that she already has the bananas. And y is the total of that. Okay, so it should be this. Now, it's not that because that's negative 10, so we don't want that. Y equals 16x. We can't just put those two together and then multiply it. That doesn't work. Y equals 6 plus 10x. These two are in the wrong spot. That leaves you just this. Y equals 10 plus 6x. Even though it's out of order as far as slope-intercept form goes. Guys, watch they're got a couple of trick questions in there, so be careful with them. Watch the discount one. That's the one that, if you're going to miss one, it's going to be that. The rest of them, I don't feel like there's an issue with. If you need any help, let me know.